Hi folks, so this is question 4. So it's a proof by induction, so these are simple enough. They're just they can get a bit long and there can be a lot of algebra in them, but should be fairly straightforward. So we're going to show true for n equals 1, and then we're going to assume true for n equals k, and then we're going to show from that it's true for n equals k plus 1. So that's just how you do in proof by induction. So I'm going to show that it's true for n equals 1. So if n is 1, then we get 2 to the power of 3 times 1 minus 1 and plus 3 at the end. So 3 times 1 would be 3, take away 1 is 2, so we just get 2 to the power of 2 plus 3. So that's 4 plus 3, which is 7. So is that divisible by 7 then? So 7 is divisible by 7. Because 7 divided by 7 is 1. So we've shown that it's true for n equals 1. Now I'm going to assume that it's true for n equals k. So I'm just going to put in a k in instead then. So 2 times 3 to the power 3k minus 1 plus 3. So that is divisible by 7. So if it is divisible then by 7, well, it has to be equal to 7 times by some number. So we'll just call it the number x. So we'll just say that is equal to 7 times some number, which is x. So you could say 2 to the power of 3k minus 1 is equal to 7x minus 3 then. So we're going to be using some of this then afterwards. We're just not sure yet where we're going to really put it in. So I'm going to show true then. So show that it's true for n equals k plus 1. So then I'm going to put a k plus 1 in now instead. So 2 to the power of 3 times k plus 1 minus 1 and then plus 3. So that then has to be equal to 7 times a number as well. So let's just kind of solve it out or simplify it first anyway. So 2 to the power of, and we get 3k plus 3 minus 1 and then the plus 3. So that's the same thing as 2 to the power of 3k plus 2 and then plus 3. Now I can change this then, this 3k plus 2, so I can split that up basically into 2 to the power of 3k times by 2 to the power of 2 plus 3. And then I can go back to my assumption. So I've assumed this up here already, so I know that yeah, so we're gonna put in something instead of 2 to the power or 2 to the power of 3k. Right, so I'm going to try and sub this in. So 2 to the power of 3k minus 1. So I need it 2 to the power of 3k minus 1. Now I'm actually going to go back a step here. I want a 2 to the power of 3k minus 1 somewhere in here. So instead of splitting it up there like that, what I'm going to do is I'm going to rewrite this here so I have a 2 to the power of 3k minus 1. So if I have 2 to the power of 3k minus 1, I need to do plus 3 then as well, don't I? So minus 1 plus 3 would give me plus 2 there. So that's what I've written here is the same thing as the line above it. I've just kind of changed around basically plus 2 into minus 1 plus 3. So that then allows me to call it 2 to the power of 3k minus 1 times by 2 to the power of 3 plus 8. So I can sub in then for this, I can put this then in instead of that, so 7x minus 3, where 7x is just a number. Times by 2 to the power of 3 is just 8, and then I have plus 8 as well. No, I shouldn't have plus 8, I should have plus 3. So hopefully then we should get something here then. So let's multiply out the bracket. So 8 times 7x is 56x. 8 times minus 3 is minus 24, and we have plus 3. And then, so 56x minus 24 plus 3 is minus 21. So this is divisible by 7. Okay, because you can basically divide both of them by 7, so if you factorize it out, you get 7 times 8x minus 3. So you can take out a 7, you can divide both of the terms by 7. So you've shown then, so you use the assumption to show that it works for n equals k plus 1. Right, so for part B then, you just have to find the nth term, t to the n. So it's a simple arithmetic sequence. So t to the n equals, it'll be the difference between the terms. So the difference between the terms is, it's obvious enough there. What do you have to add on to get to the next one? You're just adding on 7 each time. So it would be 7 is the difference, n, and then you go to the one before. So 7 less than p would be p minus 7. So that's what the nth term would be. So the second part, we just have to find the smallest value of p for which 2021 is a term in the sequence. So if 2021 is a term in the sequence, well then 7n plus p minus 7 has to be equal to 2021. Now, so smallest value for which p could be that. So we're just going to start. We're just going to start small, and then we're just going to put in some numbers for p and see, because n has to be a whole number. Okay. Because if you think about the first term in the sequence is when n is 1, the second term in the sequence is when n is 2, and n is 3, and n is 4. So we can't have a term in the sequence where n is 4.5. You can't have the 4.5th term or something like that. So n has to be a whole number. Okay, so what should I put in? So n must be a whole number. That's the most important thing to know here. So smallest value of p, so let's just start with p equals 0. And then we're just gonna keep going up until we get one where n works out to be a whole number. And that's the whole process here really. So 7n plus 0 minus 7 equals 2021. So if I bring over the 7 to the other side, the minus 7, I'll get 2028, and then divide across by 7 and see what n is. So you should get n equals 289.7, and it keeps going on. So we don't get a whole number there, so you must go to the next one. You just have to keep going. So there's a bit of work in it then, just subbing in numbers, but it's fairly straightforward. We just have to keep going until we get one where n is a whole number. So if you sub in 1, you get 7n plus 1 minus 7 equals 2021. And then if you bring across the minus 7 to the other side and add it on, and then bring across the 1 to the other side and take it away, and then divide by 7, you'll get n equals 289.6. So again, we get a decimal. And I think there's a few more to go still, because I'm just from doing this question before. If you sub in 2, so 7n plus 2 minus 7 is equal to 2021. So I'll bring across the minus 7, it becomes plus 7, bring across the 2, it becomes minus 2, and then divide by 7 at the end. And we get n is equal to 289.4. These all keep going on as well. I'm just rounding these off at 1, because when they make a decimal at all, we know that they're not right, that it won't give us the smallest value p could be. P equals 3 then, so we get 7n plus 3 minus 7 equals 2021. So bring across the minus 7 becomes plus 7, bring across the 3 becomes minus 3, and then divide by 7. And we get 289.3. Try p equals 4. So 7n plus 4 minus 7 equals 2021. Solve it again, bring across everything, and you should get n. N is equal to 289.1. So it's not p is equal to 4, so I think it's going to be the next one. P is equal to 5. 7n plus 5 minus 7 is equal to 2021. Bring across the minus 7 to 5 and then divide by 7, and we get n is equal to, yeah, we're getting 289 then. And no decimal point here, we're happy to see. So, sorry, p, oh yeah, sorry. Yeah, so n is 289. So p is equal to 5. So 5 is the lowest value then, that when you sub it in you get a whole number. So that's the answer. There might be an easier way, I'm not sure, but that's what answer we should get anyway. So that's all for that question then, I think.